Hello and welcome back to Evening Rust. I'm going to go for the quick start today. We'll get right into the show. I'm going to hop over to Coding Game and we're going to start with our quick game at the start. I'm just going to talk through it as an extended introduction and I'll give you guys a chance to join the show. And let's just do that now. We'll get into some Rust. And so I go over here and, well, we have lots of notifications first. Let's see what those are. And there's a new multiplayer game, Puzzle of the Week. Let's go back to those afterwards. Might do those, but we want to go over to Clash of the Code. We have one starting right away. Let's join a clash, and we'll see what happens here. And I'm going to let people know that we're here. We'll see what happens. So we'll see these games, if you haven't seen before, it's very random whether we're going to do any well. Rust, yes. Thanks, fair stream stuff, Rust. I'm very rusty at it, too. We're hoping in this Clash of Code we either get a speed one or a reverse engineering. I really want reverse engineering because we've never done one before. And the Code Golf ones we utterly fail at. And so we're going to see what happens with this. 16 seconds we have to wait to start. And right after this I'll go back to the coding the Tron bot. Our Tron bots did really well, even when we weren't there. So we're going to find out a little bit later how well we can make it do even better, and I'll tell you what happens with him in just a minute. And we're going to see what happens with this coding contest right now. What do we have? Alright, so we have to do it as fast as we can, which I'm going to be terrible at. Must display every other line of the given text. Firstly, your program must display the odd lines, and the second time, the even lines. First line is number 1. Line 1, the number of lines. The next line's a line of the text. First lines, odd lines, the text. Even lines, the text. Text U22. Okay, I think I got it. So I think we just need a vec here. So then a mut vec. And this is going to be a, I don't know what type of vec. We want a lines vec. So stir equals vec new. Vec new, and we want to put all the lines in here. We're going to stick them in the lines.push line, and this is all of them. We have them all in here. Now we just got to output them in the odd order. So we're just going to do this in the stupidest way possible. I don't know how to do a loop where you increment by 2, which is a real problem. I would do that very fast then. So I in lines.count, lines.len. And 0 dot. I don't know how to do stepping by 2. That would be really helpful here, because I don't know if this is going to work. And let's just say divided by 2. And it's going to have a failure here, so we're just going to say print line, and we're going to do lines I times 2, and we'll just do the loop again. Line times 2 plus 1, and we're going to get an error in one of these, but I'm just happy to say whatever. I got to figure that out because I know what I want to do, but I got to get this error first. Vec. Now what do I need here? Vec string. Uh-oh. What do I have wrong? It's just string. It's stir. I thought I had stir. Well, string works. I tried string. String works. Okay, so the first one's going to work. That's going to be no problem. One of them is going to fail because I don't count by enough. That shouldn't have worked, but just see what happens. Okay, the test cases aren't good enough because that shouldn't have worked. There should have been a situation where I missed one. Yeah, no, it's okay. It stirs. What's stir then? I thought stir was actually one of the things we're supposed to have. I thought stir was a type because I keep seeing stir, or am I misremembering that? All right, so somebody who's quicker than us here, no problem. It's fine. I did 2 loops, which is really stupid. So I'm just going to share all my code. I don't care. It's stupid. And these ones are really fun. I don't know what it would take to make this awesome. Difficulty, it seemed relatively easy. The statement was clear enough, I guess. Test case relevancy, I'm pretty sure it missed a case. I'm not sure that algorithm should have worked. I'm trying to think, if I divide an integer by 2, if it was 3 long, divided by 2 would be 1, and it would miss the third one. Or 0 to 1, or maybe not. I don't know. I just say average. I have nothing particular about that. The last guy's still working. So we came in second. This gives us some random points. But I just like starting the show this way. I won't spend too much time on these. And again, I probably could have beat this guy if I had remembered my syntax. So I made one mistake. And I didn't know how to do for loop incrementing by 2. So that'd be something I actually want to add. And I'm going to put that on my cheat sheet, something to look up. To do increment by 2 in a for loop. 2, not stir. Distract. So stir is a slice alias, basically char. I think technically it's a U8 with the guarantee that it contains a valid UTF-8. So like it's some kind of raw array. But you can't stick them in a. All right, so you'd have to stick a reference into the thing. You'd have to borrow it. So and stir, because slices you can't really copy then, I guess. Slices are always borrowed. So string probably sounds like the right size. Yeah, okay. So that would make sense why you can't stick it in a vector then. So at least we know why that is. And so string was probably the right thing there. I'm sure there's a way I could have just kept the input, because we read in every time it'd be different, but it'd be fine. So let's go over to see where we are. So again, yeah. Again, welcome to the show. This is Evening Rust, where we come over to Coding Game and we play the games. And last time we were actually playing the game called Tron, and we were doing the Tron battle. And Tron, if you see this, is this game where I have to do this, where you have to have the little worm. I'm going to say worm because this is a snakes worm game. And last time we got up to the Silver Lake, and what was interesting is overnight when we left it, the next day in the middle of the day I got a notice that we'd been promoting to the Gold League. We didn't change anything. I just suddenly got promoted to the Gold League, so our little bot must have got a lucky streak and actually made it through. And we can look at the last battles that he played. Where are we? We're at 199, so we're doing pretty poorly in the Gold League. And let's look at one we won, just to see how we won it, if we got lucky. And I'm the pink guy right there. I know, it feels like I made a mistake, but no, that looks good there. Cut off the red guy. And so now it's just a matter of how much space do we have left. And it looks like we have more than the yellow guy. And if you don't remember last time, the algorithm we use is really, really trivial. I mean, it's not trivial. It's simple in the sense of AI. It's not advanced AI. We're just doing basically a flood fill of the areas. And the spot I choose next is just based on, I check all the spots around me, and whichever one gives me the most space, I take. I consider that the other people, they consume area too. So from every other person, it consumes the area farthest to them, and so I just count the area that I have left. Alright, so Ferris is teaching us about strings. This is great. String slice and stir is just borrowed like normal. That's wrong for information. Now that's great for your information. We're going to put it there. Primitive string. I think I have to actually understand it at some point. I've been going along very well without actually understanding what this stuff means, and that's good in a sense and bad in another sense. All right, we're just going to quickly announce the show over here, so people can come join us and see what they want. I'll just copy this. I don't need the whole thing here. And compiler bumpers. Yeah, compiler bumpers. If you've not played Coding Game before, I mean, there's some fun ones in here. I mean, the learning ones, the machine languages, there's some really tough things in here, and I'm going to throw it in German again today in case there's somebody up there. Yeah. I don't know why I only get German. I think it's because I'm Germany I get German. But so I mean, it's really interesting. Some of them. The Tron one I was told was actually one of the easier ones, which I'm really happy for because we were really suffering in the first one we tried. So we're doing this one now. And what did the notice come? We're ranked 2 of 4. Good. We got some points there. Code for Life is back. I don't know what that is. Puzzle of the Week. We can check that out later. A new league. A Legend League. Okay, we don't need that. Today we're working on the Gold League. And again, the way our algorithm works, and we can watch another random one to see what happens. I'll just play this and do it full screen. A bit of it's cut off, but I hope you can see it. When it starts playing, that is. I hope you can see that well enough. So I think we just got a really crappy starting position, but I made a clear error at that point right there. I went the wrong way. I should have kept going that way, and I'm not clear as to why I didn't, because I've clearly lost at this point. So my bot made a mistake. It's a hard one to fix, because we're only looking one move in the future right now. Like, we only look at our next immediate move. We could care less any further than that. And so this bot clearly is looking further than that, and they don't. This move I would have done too. I would have, if I was there, I would have done that as well. But he clearly won this match from the beginning anyways. I don't think there's anything. If we both played perfectly, he won because he was on the bigger side of the board, and it's very hard to stop that. So the one thing we don't do, which is hurting us a lot, is when somebody else dies, we don't clear them out from the board. So we don't consider them gone, and it doesn't look like from this though that that's going to be enough to get us to the Gold League. We're halfway through the Gold League, and I suspect we're going to have to look a few moves into the future, but let's take care of the basic one first. And where was that in the code? I forgot this was a Sunday night. It was late. I was tired. Where is our board? Where's our input reading? Score scan. Here it is. And alright, so this guy is gone now. We have no guy, and trying to figure out how we do this. We have to clear him out, so it means, yeah, they knit. Basically, if knit does -1 and table is -1, I can't remember which one's -1. If they're both -1, can we just ignore heads? Can I drop heads? Heads, we have to say, can we just say they're not on the board? I wonder. I can try this first. I just filled this in quickly last time because it was failing. But I wonder what happens if I get rid of it. I think that's why we failed, is because I got rid of it. We're still dumping out the screen. Alright, we only have 2 players here, so that clearly doesn't make a difference in 2 players. Why did I add it in last time? Alright, because that's the dying condition. So this is really the dying condition. If the tail is -1, because they always have a tail, this means they've died. This player died. And we have to have a heads because... Why do we have to have a heads? Are we going to win this one? No, we lost this one too, so we made another stupid mistake. We went too far over, and we're creating these little inflections. I know what we're doing. We're creating these weird things. We're leaving out aisles of 1, and we shouldn't do that. Yeah, it's okay. It's okay, Fairs. Go to bed. We're going to be up for a while, though. If you can't sleep, come back and join us, and we'll be fighting with the worms some more. If I can figure out where I am in my code. I might have to go to bed early tonight, too. I'm going to be tired, but let's see where we go. Alright, so where are we? And this player died. I want to check my code. Do we have to push onto heads? So each turn, where's heads used? This is really hard in this editor. Heads, heads. Each step we clear all the heads, so we have no players. Aha, because our heads, these are in order, I think we have no choice but to stick something in there. And each score location, player ID, yeah, so if our player ID is wrong, our heads is going to be wrong here. So we have to have somebody in all the heads of the board. So let's push a -1, because we already know these are negatives. And then wherever we use heads, we'll just realize that there's nothing for -1. Okay, and we're okay here saying the board state of this player, because this is us. If we're -1, we've lost the game. Doesn't matter if we crash at this point. And heads, and heads. Okay, so I think it's the fill function. Because all the scores are fine, just the filling is wrong. The scores we should keep because that's not going to be on the board. And so where do we have fill? We have heads right here. If heads I dot 0, I guess it is equals -1, then we'll just continue. So if we have a bad head in there, we're just going to keep going on and see what happens. Otherwise, we'll push them on here. There's no open locations, and that's okay. This just keeps them out of the loop. And so now at least we'll not crash. But we also want to clear up the board. And we have a board. Where do we have fill? We have a fill play board. Okay, and we should also clear the board. We want to clear player. And this is going to be P. Now, what's our board? We have this is in the state. So, and self.board. This is probably going to be a mute. Yeah. And we're going to do player ID, so P. Then we have to go clear the board somewhere. Alright, here we go. I forgot what I called it. This is always a clear player. That's what it was, clear player. It's way at the bottom. Again, I hope I can't change the font size here. I hope you can see it well enough. And the player is just an I32. And we just have to iterate through the entire board. And I had a function that did this. What do? We had the linear gets. So right here is a typical one. And I need to copy this loop first because I don't remember for sure what we did. So I'll copy this loop. The iteration over the entire board. This is linear iteration. It doesn't matter. We don't care about x and y. We're just going to linearly go over the whole thing. If P, and we say if P equals player. So this basically, if this is a player square, then we're going to have to actually clear the board out. Play board dot linear set, and this is going to be I comma. What did we set? We said free cell, yeah. I set a constant, so I don't have to remember what that was, but I still remember. I think it was -2, -1. Block cell and free cell. Okay. So if it's that player, we get rid of it. So we clear the board, and we should see that when they die in the multiplayer, but we're going to actually have to submit to multiplayer then to see that. Let's just do it. Let's add another player here. Let's add the Cookie Monster. And let's play against him to make sure it's working. This is actually kind of a neat feature. I can choose random people to play against. Wow, this takes forever to start. Okay, so we're doing well. And we're going to look back when one of them dies to see if we actually write in our output that they actually died. And that's what we're going to check for this time. And we're doing well against these guys. Like they're in trouble right now. They're both in trouble a lot. As long as I don't screw up. Red's dead. Oh, that gives blue a really good advantage though. Because suddenly blue has all that spot there. And did we clear it out though? We're going to find out right away. So that actually, by red dying, it really helped blue, and we die. But let's see what we have in the end. This looks like what we have. Well, we have our final stream of where we are, and that looks like blue, but one is gone. That's what we wanted. Where does one disappear? Let's scroll back. Again, I really love this feature, scrolling back in the video. Okay. So you see one still here, 1, 0, and 2. We printed out the board, so we have 0, 2, and 1 is the red guy. So we scroll down. We're going to find out where red disappears, and that's number 1. And so red's going to disappear right about now. So we have all these 1s. Red dies and is gone. So we have an open board now. And we can't do anything to recover about it because we're stuck up there and blue has all that space. Let's see if this gets us any further in the competition. I don't know how much it'll get further. We're just going to submit it. We have nothing to lose. I mean, we'll lose, but we don't really care about that much. And we're going to have to start looking into what we do now, whether looking one move ahead is going to be enough, or whether we actually have to look 2 moves ahead, or actually start coming up with hand-coded strategies. I mean, like, I don't know what we did here. We did something stupid there. So our scoring is wrong. We have a fundamental problem in our scoring. When we were over there, we shouldn't have gone back that way. That was really weird. I don't know why we did that. I also think we have a problem in multiplayer. I wanted to test something else out as well. Now, when we have multiple players, we subtract all of their scores, which might not be correct. It might be better to just subtract one of them, like the maximum one. But this is looking good here. So, I mean, we do sometimes make the right decision. Not there. See, that was a pretty shitty decision, but we don't look far enough ahead to actually understand that. And this is where, but we somehow won that one, which is really, it's questionable. We should have noticed the one sort of point, the choke point, and our scoring should have recognized that in the choke point, that stuff beyond the choke point isn't worth as much, because we can easily cut it off. But actually, why did we cut it off? So we had an error there. We cut it off, so we must have been making a mistake. Ah, I know why we make that mistake. Yeah, I remember. I know why exactly. I know exactly why we make that mistake. And let's play back to that one. Can I go back to that one? Oh man, I gotta figure out which one that was. Which one was that? We're winning a couple of them now. Not good enough, obviously, and I'm never going to find that one again, am I? Where am I going to find it? Alright, so anyways, what I want to say is that when we have those inflection points, and or whatever you want to call them, choke points or something, we have the issue that we'll walk right into it and we'll split our area in half because we're still counting both sides of it. So when I go to the wall, I count both sides of where my head is, even though I can really only count one side. So what I really have to do is I have to pick a side. I don't pick all sides, I have to pick just one of them. And so we can probably change the code to do that. So that's in our scoring here. How do I do that? How do I score that? Because I have an algorithm right now to fill. It fills them all up. And so we take all the heads, and then for each distance we walk by it and check them again. Is it somewhere there? Is it somewhere there? Is it somewhere there? And what we should really be doing is we should say at the start of this we should be picking just one direction and calculating it. It won't be completely accurate, but it will get all of it. It will figure out that we actually have something broken off. So for the heads here, how do we decide that this is the first one? We only want to check one direction. We don't want to do this totally inefficiently. It's like from this head I want to push just one direction off. Because it cuts it off. Actually, wait a second. What do I call fill? Maybe that's the problem, is fill is actually doing it wrong. Fill. Where are all our heads? Our heads are all there. Okay, score location. Where's score location called? No, but we do it right here. Equals location. And I think that might actually be incorrect. I'm trying to think of how we block it though. How do we block this so we can't go across both sides? So what we're doing is, like I say, we have the line up, and we have to block it. So when we test the location, we can't score both sides. The fill has to just go to one side. And I'm trying to think of how we force the fill to go one side. So in the score location, we are here. We set the location. So we actually set the board to location that's good, and that's the head. And then we set the head, that's fine. And then we go to fill. And we push the head location. This is where it's a bit weird that we shouldn't be pushing the head location. We should be pushing the first free one of the head location. Take anything beside the head and fill it. And yeah, so anything beside the head, and we're going to fill it. And that won't give us the correct score, but it'll give us one of the potential scores. And that should be enough to block it off, and let's see what actually happens. So we're actually going to do it this way: for and D in and left, up, right, down. Let NP equals heads I dot lock. No, that already is the location. Step D. If not board is free. Actually, wait. If board is free, and play board comma NP. Then we're going to push that as the head location. So comment this out just to remember what we were doing. And so here, take only one direction. In case we're splitting. So we'll take the one direction that has the first one that's free. This is obviously not the best approach. We should actually just be measuring all of them with separate fills, and then we'll figure out if we set them all with separate fills. Then we take the one with the biggest, then we have the better score that way. But then we're going to actually have to store bigger values in the graph, which is okay. Okay, let's see what happens though. Board is free, then we send P. Then we'll try this first. Push back, open, and the lock is NP. Distance, and we say the distance is 1 now. That doesn't matter, say it's 0. The player is I32. We're going to start them all at 1, and we'll break out of this loop. I hope this breaks out of just this loop. And so that'll get us exactly 1. And we'll only go in one direction now. And I wonder how much this actually buys it. That'll prevent us from doing at least some boneheaded moves that we were doing. We at least won't be cutting ourselves off now. And we're doing some weird stuff there. And what on earth did... Okay, that's because I'm not looking far enough ahead, and the blue is already cutting that off. We're going to lose against blue here. Okay, and you notice when I made that mistake, let's pause this. Actually, I don't pause it, I want to go back. I want to show that one step. What we've done is perhaps not so good. Because from this position here, the reason we went down now is because the algorithm probably checked this step here. And it's like, okay, from here, how much can I fill? And then we just took the next direction and said, well, we're going to try here. Oh, we have 1. So don't go there. And so we went down instead. But what we should have here is we should have actually filled this and filled this. So we at least went there. They'd fill it in a bit more. But this becomes a little bit more difficult for scoring. And what we can do is we can give the opponent maximum scoring and just track us, or we can do this for all players. Actually, let's do this for all players. Let's actually do an additional fill scoring. And scoring is going to be a bit challenging now. We're going to have scoring as... We're going to have to fill this with a lot more. So rather than previous player, we're actually going to do all of these things. And this and D, how do we actually do this? Let's see, let directions and ders equal this. Then say for D or I in, no, J now. J in 0.d.len. Directions J. So there's always 4 here. And so we're going to fill it, every part on the board, we're going to fill it with a different number. And so it's not going to cost, it's for algorithmic time, this is exactly the same. It costs the exact same amount because we're just filling it with a different number. Our scoring is going to have to do different though when we count it up. So we're going to say I plus, let's put a second line here. I plus j times, how many players do we have? Heads.len. So what this means is each player has 4 counters. So each player has 4 counters, and the board's going to fill up that way. Now when we go to scoring, though, we have this. We have the scoring right here. We're going to have to say, okay, if P is less than 0, continue. This is a block cell. It shouldn't be a free cell because it can be a free cell too because they'll be blocked off parts of the board. And now we actually have not num players, but num players times 4. And this is like a magic number now, unfortunately. And it's the number of directions. Where do we have our constants? Num directions. We'll just put it here for clarity. We can make this a use size as well. Why not? So we have times num directions, and this is okay because this will be enough. And this should be num players as 32, num players times num directions. I don't know what order as is, and we'll add the score that way. But now we have, for each one, we have to find the maximum score. What is the best score they can have in each of the positions, and that represents the true score of that area. And how do we do that? We're going to make a new scores and let mut max scores equals vec. Zero I32 num players. I in 0 num players times num ders. Again, there's probably a nice Rust-like syntax for actually getting this to work. And how do we do this? Max scores I equals max scores I dot max. Not I, no. So let index equal I mod num players. Index max, and this will be scores I. I guess this is scores.len here. Now hopefully this doesn't fail horribly on me. If you don't quite understand what I'm doing here, I filled in the board with potentially up to 4 numbers for each player, depending on the direction from the start. It'll only ever be 3 because you can't go backwards, because potentially that step could fracture the board into different areas, and the score for that area should only be the biggest one. We can't add them all together, and that was a mistake we're making before. And so now we should hopefully fix something there. And I have errors, of course. Alright, 208. 208, we need a, here. Constants need a type. Alright, cannot find value D, 247. And dirge.len, yeah, dirge.len. Mismatch types at 218. Num players times dirge. Okay, so this is actually done this way. Whatever, put it like that. More errors, okay. We still can't make this any wider. I can make it a bit bigger, but doesn't really help. 226. We got slightly better in the ranks with that one fix, 187. I think that put us slightly better in the ranks, but not a lot. So that one fix with them dying helped. So max scores index. Yeah. Done max. Alright, what do we have? More errors. No more errors, might be running. So it was running. We did something really weird there. Why did we decide to do that? We followed him, which is good. Why did we not follow further, though? Blue's going to totally kill us now. But we might be okay, because red might die. As long as we don't do something stupid like what it's about to do. Like that. Oh, then we actually won, but that was more by accident. See, we made the same mistake there. Why did we not go into that corner? And why are we doing that way? Oh, I know what it is. Wow, this actually gets a little bit weird. Yeah. Okay, I know what the problem is here. What happens is because I assume we're splitting the areas, but what if that's not the case? What if the two areas actually connect? Then we actually have more to fill. It's a bit weird. I'm not sure how we do that, though. How do I fix that, then? I guess if one side encounters the other side, and it's a lower distance, I'll just submit it, see where we go. So we're at 187. Let's see if we actually get a lower rank now, because that could totally screw it up, that rank. I'm really uncertain how to make sure they're joined together there. What we could do is override it. If we hit the same value, if we hit our own player, we can keep going. But the question is, how do we evaluate that? How do we actually decide which one goes? That could actually be a bit slower then. And we're making some bad makes, and we're doing worse now. We're going to end up doing far worse this time. Because I made a mistake, and that's not a good one to make. So did we actually win any of them now, or is that mistake pretty much fatal? That mistake's fairly fatal. How can I actually do this? I only want to fill it up with the second one if I actually have it split. And so I'm trying to think of an area, if we have put it there and it's actually split, and split means there's no way around it, but we could check that fairly quickly by checking the containing conditions. If the one right beside it isn't full, then we know it's not split, and we can just leave it alone. Or if we encounter ourselves, but if we encounter ourselves, we're going to overwrite it, and it's going to take very long to do. And how can I do that? It's a very interesting problem. I don't know how to do that one now. I might just live with the split for now instead. And worry about stepping one into the future. If we step one into the future, it might solve the problem as well. Because stepping one into the future, we're going to suddenly realize that we made a horrible mistake. So it might actually be a better fix to just not do this fix and actually step one into the future. And that'll be in this heads here. Oh, well, we put the brake here, so that would actually make it worse. Forgot to take out the brake. So that wasn't a fair test. We might still do something stupid, but let's take it out and let's see what happens. It's still going to do something weird because of it, so... It'll still be weird, so I think we should probably do it. Yeah, and Clay, I'm not actually worried about two having the same score. I'm worried about us not calculating the score correctly now. We have this situation where that score, the maximum when I split it, is my algorithm works when I split the area, but I'm not always splitting the area. I'm counting it wrong. And so what I should do is I should actually just looking one move into the future actually fixes this entirely. So instead of trying to fix this cleverly, I think I'm just going to go to the next step and make us look one additional move into the future instead. Because that'll actually fix the error I'm trying to fix right now without any clever logic. And so let's just do that instead. We're just going to push one. We're going to take this away instead. Go back to the old approach. And our scoring will still be fine. We just won't have any of the other people on it. But now we actually have to do the next step. And this is a bit more difficult, is I actually want to do another step into the future, whether it's okay. So for each direction, we're going to step one into the future and check the whole direction again. So where do we do that? We have a... Next direction, we go into a score location. And the score location, it goes into all of these things. And we're going to test each one. And this score location is going to do the same thing in reverse. It's going to do it again and again and again. And we need to set up some sort of recursion here on this. So for each of the directions, we want to score the location and how far deep we want to go. So I'm trying to think of the syntax for it. Score location. We already have score location. Score step location. We don't even actually need the state anymore. This is where it gets a little bit ugly. Do we want the state? Yeah, okay, let's start with the state. And I can't quickly run through this code anymore because each state move, I want to clone the state and then test it, and then clone it again and test it further. And the score location does a cloning, but we actually have to clone the whole state now as well. And I'm just trying to think of how to do that. Okay. What do I want to copy here? I want to copy state. Let's just start with next location. Next position is a point 2. And what I want to do is where do I want to clone the state? So the initial one I can step, I can score a location without copying it. So the initial one I can score all of it without copying it. So we could simply say depth here as well. Depth is going to be an I-32. And Alright, this is getting messy. I'm trying to think. I'm thinking in my head, and how do I step this? I step it forward, and I want to step it 1 forward so that we have each move, we have actually an explosion of 9 potential steps. And I just want to do all 9 of them. I think it's going to be fast enough to do all 9 originally. And that'll cover up the one case we have 9. It'll cover up all 9. It'll cover up the stupid situations. But it's 9 iterations. I'm trying to exactly see how I actually fit it in here. So we're actually just going to step each location. So we're going to skip store location. So if we're stepping to this location, we have the board free. And we'll assume we're stepping to here. So then we actually have to do a state.clone. So this will be state.original. We have a new state equals state.clone. Will this actually clone it? Our state has a clone. It has a board matrix. The board matrix has a clone. Matrix has a clone. Has a player ID, and it has heads. That's perfect. Everything should be clonable. Matrix is clonable, so we can clone this. We can clone the state wherever we did that. And now we're going to set the player on it. We're going to say state.board .set np, and what's our state.player index? I think is what it was. Where's that? Hello, where are we? Where's our state again? Man, I can't have 2 windows open. It's kind of annoying. I'd like to have the code in 2 places. Where are we, state? Come on. Oh, come on. Even there it is. State. Player ID. Perfect. Player ID, board, and heads. Player ID, board, and heads. That's good to know. So we're simply going to fill this state. In this move here, we're going to actually fill the state. And then for each of the next players, we're going to actually fill the state as well. And we're just going to fill some random state for them, I think. And I'll explain later why we actually don't want to do that. But let's just fill some random state as well. So we're going to have this for I and 0 ... extra p player IDs. Now this should actually be done in the order the player is going to play, but I'm just going to rough it in right now. We'll do the fine details. I'm assuming I don't need to get the fine details right to get through the Gold League, because our algorithms are going to do really well or really poorly, and the fine details won't make a difference. In the state.heads, okay, .len. And we said if state.heads p dot 0 equals -1, then we don't have a position, so we just continue. This player is dead, they're not there. Or if P equals state.player_id, then we continue because that's us. And so now we just need to find a suitable play for the next player. And we're going to go... We could actually score their play. We could actually actively use our algorithm again to figure it out. But for now, we're just going to pick the first one that comes up. Just pick them from random location. We should actually take the location that goes closest to us. I think that's clear, but it's hard to define. With an A star closest would be perfect. The A star closest location, they're going to run right towards us because that's the worst thing that would happen to us, is them running towards us, I believe. And that would be the minimax strategy, take the worst thing they do. But let's see what we do if we just take any old position. And we're going to have to do the same thing here. Just walk through these directions again. I keep copying this. This is really bad. I shouldn't keep copying this, but I have a hard time making these simple structures like this. So now we have state heads P as use size, steps in this direction. If the board is not free, then continue. Or actually, if the board is free, then we're just going to set that. We're going to say state board.set. This will be the NP. It's okay, we can reuse the name as P. And then we'll break. And so what this score step block does, or actually what this, I should call this is, this takes, every player takes the next move for each position. And then we're going to score it. And then we're going to score the best direction on there. What's the best potential score, or the average score. How we combine these scores is a bit of an issue now, because when we're checking all 4 locations, or all 3 of them, it's not certain you want to take the one that has the best score after 2 moves, or the one that has the best average score, the one that has the most possibilities. We'll just take the one that has the best score after 2 moves. We won't worry about it. So we have this new state, and now we want to figure out in this new state, what's our score? What's our score in this new state? And so we'll take all the moves again. I can't really think quickly enough how I want to duplicate this. Let's make this, let's do something special here. Let's make one that returns a tuple. I'm going to give it a state. State, so this is going to have to be... All we need is state, because this is for us. Score next year is going to find the next best score, and it's going to find a score. It's going to find the direction and the score. And so it's going to be basically the same thing here. I'll copy this out for now, so when I modify it, I'll know what's happening. And then we'll probably just delete the one above it. So we do all this, states heads, and if we step, the board's not free, if we score it to the best score in the best direction. So now we're going to return best direction, best score. And so who calls next direction? So next direction is going to be simplified. Well, not quite. Let's do this. We still have to score each one, but between each step, this is where we're going to change it. And we're going to say score step block. And we're going to give it our state, the current state, the position we want to go to, and the depth, which is going to be, well, I haven't used this parameter yet. We do exactly 1 step. So let's do 1 depth. We return the best direction based on that. And so what this does is I've copied the code 3 times, and it looks pretty bad. But what we do is next direction now, what it does is instead of just calculating a score For each of the directions possible, it calls score step block. And score step block actually mutates the board. It makes all of us step once. All of us take one turn. Each player takes one turn. And then it's actually going to return the best score there. So return score next direction from where we are right now. And that'll be the best score of this one. So after we've taken all these steps, what are the resulting scores? And I guess we take this value off here. And it's going to return that. We don't use depth, and we'll show how to do depth afterwards. I want to see if this actually works now, or if we've just done something really stupid after we figure out the errors. Okay, 336. Oh, I guess that'd be state clone. Oh boy, oh boy, boy. What's this here? 336 again. This probably creates a cascade of error messages because if state clone wasn't known, then state's not known. Not found. I guess we need the directions as well. And let's try that. That's probably enough of a screw up there to cause all those cascading errors. Mismatch types 305. Okay, this makes sense now, 305. Because what we had, so we actually have score direction comma score actually. And score step block actually returns direction comma score. I-32. Okay. Alright, 341. Oh, someday I hope they'll fix this editor. I haven't pressed the page down button so much as in the last couple of weeks. B equals state player ID. Expected blah blah blah. On by 32. Okay, and that's the same one down here, 351 as I-32. Oh, this is getting annoying. 240. Why can't I do this? Unused variable DIRs. Because they were used here. We need to put it in here too, DIRs. Then it's used. Of course, I probably have the borrowing wrong. Okay, and so that one there is we have a one that's not used at 304. It's correct, we don't use the direction here. We don't care about it there. Score step block should probably not return a tuple, to be honest. No, score step block should just return an I-32. It's returning just a score at this point. And we'll just ignore the direction, and the R score equals this, and then we'll return their score. And that should be good, then we don't have to ignore it. So score step block is just a score. That makes more sense, because we don't care which direction the last thing goes. And should be enough. Uh, 260. Now I knew this would cause problems. Now let's try to figure out what the actual problem is. So I had this as DIRs up here, and I have a DIRs down here. I probably have to borrow it again. It's like, it's not like in C where once a pointer always a pointer. It's like you have to keep borrowing it. unused variable depth. Alright, so we can ignore it for now using it a different way. Depth. So apparently if I put an underscore on it, it's safe to ignore it then. Alright, so it's actually doing something now. Did something horrible. What went wrong now? We did something wacky. We walked into ourselves. Okay, we did something pretty bad. Okay. So, score. Next step, what we do, we would check this out again. For each of these directions, if the board's not free, we don't step there. This is fine. Score step block. If it's a better score, best score. Okay, good. Score next step block. What's it going to do? It takes this direction. It clones our current state. This is fine. And then it sets us where we are. At the next position, it says, well, put our player ID. And for all the other heads, ones that are existing, it says for each of the directions of those heads, if the board is free, well, it takes the first one and sets it, yeah, it sets that value. It should be good. So we set one in each one. And then we do score next direction. And score next direction is going to take our current heads of all these heads. And wait, we didn't update heads. State.heads. State.player ID equals NP. We have to update the heads. State.heads P equals NP. So we solve P equals NP at the same time. Great math problem. So, you know. Wonderful variant names. So we update the heads. Let's see if that was enough to actually fix the problem. No. It cannot be applied to I32 states.player ID. Again, this will do a lot faster than a page down. I keep losing my spot. This is why I don't remember where the code is, because I have absolutely no feeling for where this code is in the file. Because when I go up and down the whole time, I really have no idea where my functions are, and that slows me down. It's really slow sometimes. Okay, let's see if we do anything stupid. We walked away for them. I'm not sure if it was necessary. We don't necessarily be doing something so good here. What on earth is it doing? Okay, so we don't kill the inflection point there. And this chose a better path here. We're going to fail, though, because we don't have enough space left. And the red one has all the space in the world. And I think this had to do with our initial algorithm. But we could have gone against the wall here, and this is tough to say. Because that splits our area in half, and we lost space. So that's probably why we never went to the wall. But in that case, it probably would have been okay. It's hard to say if that would have been okay, because in some cases it's okay to split the area. In some cases you want to split the area because it cuts off the opponent's score as well. But our scoring should be taking that into account. Or maybe not. Let's try another one. Let's just submit this and see if we get any further. Okay. Really? There's a Firefox plugin for using an external editor? Someone. Do you have a link or anything to it? I can try it offline then. Somehow we won this one. Yeah, I think this is because we started in the right spot. So we made a very good move there of cutting him off. Let's watch a few of these. So clearly we beat him. That was a relatively easy one, though. And I think we're probably going to win the 2-player ones. And the 3-player ones... Oh, wait, go away. Birthday party tomorrow. So we didn't do it. We didn't make a bad decision here. We did right, or maybe not. Did we do a bad one there? Ah, yeah, because we cut more data off. I see why we did that. It wasn't enough. It wasn't enough. We're still going to get trapped first. But at least we filled in our area. So the red ones also made a similar type of mistake. It's left all of this open when it could have been going up and down, up and down, up and down, up and down, up and down. And here it's also made a mistake. So you see how easy it is to make these types of mistakes. Okay, and let's check another one. I want to see what type of mistakes we're making. So those other guys just screwed up right away. Don't want to happen to them. And the reason we go back this way is because we see him and we're trying to cut off his space. And we're trying to stay safe at the same time, but we should have just cut him off now, unless we do something stupid. So now I don't understand. Our behavior now is really weird because we're still competing with him. So he still has open space. Well, we're still doing something weird there. I can't explain what we're doing weird, though. I mean, what we did there was really good up until now. But let's see if we optimize this remaining space. We have nothing to compete with anymore. I mean, this is looking okay. Now we open it up and why don't we cut him off? Something weird there, but he screwed up somehow. We might actually be doing better this time. Like, we go right into the middle of that. It's because our algorithm is checking, we're taking the score away from all of them. Anything we could do to reduce all of their scores, we're doing. Which may not be the best for us, though. Oh, we just screwed ourselves up there. Purple is doing something really interesting. Notice the weird pattern it made. Alright, this is a coding game link site, so I can hope it's safe. Oh well. This is going to be a problem because I don't have Java installed. Is the Java application... Oh, I can run separate Java applications, but if it's not... I hope it's not a Java plugin. It should be fine. I'll put a bookmark on this, and we'll see if I can get this working next time. And why do I have messages? Oh yeah, this is just them talking about those things. So we're not doing a lot better with this. Is it because we're not looking far enough forward, or because... I mean, we are running some. Like, our streak breaker is actually looking a lot better than before. There's a lot more in the leftmost position than we had before. So I think we are actually doing better. just not better enough. and there's some, clearly we're doing a few things just weird. Now we can check the depth thing and see how far we can go in the depth and let that run and see where we get to. Or actually, let's check the leaderboard, see if our position is going up or not. Like, we have to get quite high, I think. We are going up, but not very fast. I don't know, maybe we get lucky and it gets better algorithms perform better. It's unlikely. The only thing I can think to change, and this is really long to test how this does. Like, it's really hard to test out the strategy because we have to wait a very long time for feedback. We can sort of see from the things we're not winning enough, we can just try to fix the ones we do win. And what I actually wish is this actually shows our win rate. This would be great if we showed the win rate right here, or is this actually the win rate? It doesn't say how many games we played. I just want to know the percentage so I can check a lot quicker, am I actually doing any good? Okay, so how do I do the next one here? I want to do... I think we're going up too slowly. I mean, I don't think we'll ever get to the top at that rate. Let's think of what we could do. We could try the depth thing. We might be going too slow, though, if we just increase the depth, but let's see first. Let's actually get the depth stuff working first. And when we do the steps, what we want to do is when we do a score step block, this is the first thing we do, is score step block. And this is each direction has to be checked. And for each of these directions, we want to test a variety of scenarios, what we check. And the first thing we could do is we can try and make the opponents come towards us. And that would be like the worst case scenario for us. I think this worst case scenario, if they're coming toward, if they're going away from us, it's great. Gives us more space. So now we want to find the best case scenario of them coming towards us. That involves, unfortunately, another flood fill basically operation. But if we keep the operation from before, no, it's hard to say. So the quickest point between 2 points is going to be, yeah, that would be an A star. A star is basically a flood fill, but I'm thinking if we could do it any faster, we don't actually have to find the quickest path. We don't really need the path, and that's the point. We just need to know which position's closer. So if we fill it up, but I'd prefer to not do that first. I prefer to just somehow step further at random. And is there any way to shuffle these? Because we always check left first, and it always goes there. And I'm trying to think of where, if we could just shuffle these, just choose them at random. That'd be better. How do I shuffle? How do I do this in Java or Rust? Not that I want to actually shuffle these, it's just every single time just take a random sampling of them. Well, let's figure out how to do a random value first of all. Or should we just have a counter somewhere? Do we want a counter? That should be sufficiently random. It sounds really stupid, but that's okay. Step C, I'll leave it ambiguous as to what that is. 0i32. And now we want to do this. We want to say there's 4 directions to test for di in 0.3. Which location do we want to check? So we're at 208 now. And remember, before we made any changes, we were at like 186 or something. So we have to really do well before we get better. And that's a dn actually. And let the d-index equal, let di equal dn plus step c mod 4. And we can make this a u size here for consistency. This is d as u size mod 4. And then we'll actually take the direction here. And let's make this directions global now. We use it actually enough. And where do we actually set this thing? Where are our directions? Where's the one where we first set them up? I want to duplicate it. Dirs equals. Okay. And we'll just stick this out here somewhere. I'm going to say all dirs, and maybe we're going to fix it up later. All dirs is equal to this. And so where do we have dirs? This becomes all dirs. And wherever we were before, I don't know if we can do bookmarks or anything. And we can also do all dirs here. All dirs. And where do we have the other one? And there's another all dirs here. And what do we want to do? Where's the code I was actually working on? Yeah, so now we, whoops, too much. And this will be all dirs di. And this will just change the direction a bit. And so each time somebody makes a step, we just increment this value. This will be enough to just basically make sure all the players always have a different value. And of course, let's stick it inside the loop so it's somewhat semi-random. This should actually be random. I'm now thinking this should probably be random, but not that. And this will at least check a different one. This won't fundamentally change what they do. But what it can do is it can set up the randomness so that when we do this player, we can actually make them step random directions. And we're going to take a sampling of which one's the best, which one's the worst. And so after each state, we can score the state. And for this state, we step all. So we could step multiple steps, though, instead. And for our player, each step of the way, what do we want to do? Will our player take the best step again? Or do we just make the player take a random step? And so we could actually just make every player take random steps. And maybe that's an option. Each player takes a random step. Okay, we're at 180. Let's see if we're actually going up or down. Scroll down to 180. I want to see how much better we have to actually do. See, we're going down now, so we're already screwed. We're not going to get to the end. We're not going to get high enough up. So it's 17.76. I don't know what that value means yet. I haven't figured that out. But it's way too low. I think it's probably wins minus losses or something. I don't know, something like that. But we're simply not high enough, so we really have to look a bit forward. And if the looking forward doesn't work, then we're actually going to have to start doing clevery things. And what I haven't set up yet is I haven't set up the recursion yet to check multiple depths. And this is why, again, the step C is so that I can check a random location. And what you do is, if we have to go to significant depth, you can't just spread out and check all of them. You want to actually check just a certain number of them. But if I could just set it up to at least check all of them, it'd be good. So we do this one step, and now I want to do another step. I want to do this again. And why do I want to do that again? Why do I'm hard recursion. In the recursion here, I want us to do the best move. After we've done all these moves, I want us to do the best move again. And this would be based on scoring. We would take the best move. And that would be score next direction. Or do we go right away to the Monte Carlo system where I just try a whole bunch of them? I'm just trying to get the recursion right. I'm just having to think in my head. So the next direction we don't care, that's the outer one. Score step block says, given this initial step, how much value is there? How much value is there in taking this step? And that's basically our recursion. And we want to sample it. And so this does one step. But now we want to say, well, if I take another step, how much value will it be? And if I take another step, but each of those steps we want to say, are we going to take the best step or are we just going to try one at random? Sorry, I'm thinking this very slowly through. I'm not working very fast today. Score next direction is very clear. The board's free, we score the location. Scoring was very straightforward. The scoring algorithm may not be perfect, but this definitely does the scoring and definitely says from all 4 of the locations which is the next best step. Okay, so maybe that's good. So this is the next best location. And so now we can actually check the depth, actually. Let's do that. If depth is greater than 0, else we're just going to return the score. If the depth is greater than 0, we can actually do this is where a recursion happens. We have the state, and we're going to say np dot step direction. If we step to this direction, and we're going to do depth minus 1. So we start at 1, so this will be 2 depth. So we go 1 down, we step to the best location. Then they just step somewhere again like idiots. And then we'll just keep going. And so we're going to do 2 depth. And what does this help us? It just goes 1 further down to say what the score is going to be. If we keep following the best one from each side, what will our score end up being? And this will just go down to 2 steps as opposed to 1. Expected item found let. What's wrong with that? Why can't I do that? Hello. What's wrong with that? Expected item found let. Can I not have a global? I gotta look this one up. Rust globals. Rust globals. Rust global variables. Why is my let not working? Static. Is it possible to use global variables in Rust? Huh. I don't know what the type of this is. Well, let's try the static thing first. Static probably can't be a reference. But I really don't know what the type of this slice is. Well, let's take the reference off. Okay, so we have trouble here. So we do need a type. Alright. 232. We'll try that. It's a rolled array of enum type. Oh, so that's a different one now. That's fine. Okay, and that has to be a static as well. Yeah, okay, fine. That's fine. I think we can get away with that one. 336. This is a static. I don't know if statics can be mutable, but this is going to require a usize as well. Did I not type enum type? Did I do something stupid? Sorry. Yeah, I know what you meant. I don't know why I typed enum type. That was dumb. Alright, so we're not using directions now. That's clear, so we actually have to type in all the direction names. And I'll put this in a new line just because we have such a short area here. Direction right, direction down. And that's probably enough that it causes all the other errors. Unused import, unused, that's 236. So we don't use that anymore, that's fine. 340, which is now 339. Okay, and so all dirs, this might... Do we not need this? Let's try this first and see if that works. I don't understand the rules for statics now. But that's looking better. 299. So if it's a static, you don't have to borrow it because it's already a borrowed type. And okay, and 366 step and state. All right. Use of mutable static requires unsafe function or what? Why? 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 Just why are you doing this to me? What's wrong with a mutable global variable? How do I do a mutable global variable? Rust mutable global variable. Lazy static. What? That seems complicated. No. Okay. Do I really have to do this? What on earth is this for? I don't know if I can use crates though. What do we have? Another option. Alright, I don't know how to do a global, and this looks initially confusing. There must be some other way we can do this without doing a global. Because I don't want to import a crate, just do a global, but why can't I just create a global variable? can't really pass it around in the state because we keep cloning the state, so we never have the same. Fine, let's just do random variables then. If it's not going to let us do, I'm going to put that in my notes. I'll have to figure this out, how to actually do a global mutable state. Global mutable variable. Like a counter. What do we have? Now we want to do Rust random. Random number, then Rust in a range. Gen range. This looks weird. Alright, let's look at the docs and let's see for something called random. No, I should check rand, not random. They love rand short names. It's an issue when people don't like typing long names. They have short things and it's actually hard to search for. Random. I don't see anything being random here. That's all we get. We get alright. Turn create rand, use rand range. Yeah, I get that. I think that's why it's saying it's unsafe. If two threads attempt to access it, it would be unsafe, but I'm totally okay with it. I just have a single threaded program right now. I really just want a way to keep a global counter. Is there a range? None of this says, so this is create range rand. Now why does this not come up when I look for rand? Right, if I type rand here, it doesn't come up. So their docs searching needs some improvement here. Okay, polymorph thread local. Just tell me how to use it. Use rand range. Let's see, let's stick that at the top. And I didn't even compile this once first to make sure we can use this. Not that there's something weird here. Unresolved import rand, so we can't use it. Well, that's problematic. So we have no way to create random variables. The other way to do a random variable is the global state. So let's see how we do an unsafe. Can we do an unsafe global variable? That's my next thing. Rust unsafe. I'm just going to do unsafe because if I can't use random, I need some way to keep some sort of entropy involved. And how do I mark something unsafe? Unsafe. Okay, do I have to make the whole thing unsafe, or where is this? Do I have... Where's step C? Step C? So let's do this here. Can I just do this? Take my guess and see if I can do that. Static variable. What? That's an error? Oh, come on. This is becoming pedantically annoying. It's one thing to have a convention, but to force it, that's because of the lint level. Okay, whatever. Now I have to find alders. Okay. And up and step C, because also it's a I'm actually a strong believer in languages should not require an IDE to write correctly. It's because I saw Java being used to that much way, where Java stopped being a language and Java plus an IDE became the language. But again, this editor is terrible, so I mean, a basic search and replace and a normal editor will be fine as well. I don't really need refactoring here, I just need to do search and replace. Does it actually compile this time? Let's see if it crashes on us. If we did something weird. It looks like it's running. We're doing some weirdness, but okay. We lost this one. What on earth is our bot doing? It's making some bad decisions. Very, very bad decisions. If it wins, it's only because it got lucky. What on earth is it doing? Okay, we got lucky, because look at all that wasted space. I'm trying to figure out why we have that wasted space. Okay, this one I can understand. The one right here I can understand. This one over here, that seems weird. Hey, but look, our last bot got to 62. So it was still climbing the board. So those changes we made before actually helped it out. We didn't make it far enough, though. So at 20, so we did actually reasonably well. Those were just the first step changes. So now I'm going to try something ridiculous now. Score step lock. Where do we call this? Score step lock. Let's go to a depth of 3. Let's see what happens when we step 3 moves. Let's see if this actually helps, or we're just confusing. I'm just deluding myself that I'm actually doing something. This should improve, but it may not improve one game again. We had to test hundreds of them. I mean, but so far, if we're actually improved a lot. I certainly like it so far. It certainly made some wise choices here. Not there, though. That was stupid. It sometimes makes some really weird choices. Like if there's too much area, it doesn't know what to do with it. And it's going to go there and come back, but... like, why? Why? Okay, so it's when it has too much area, it makes a bad choice. Kind of. What I'm doing is I'm doing multiple steps ahead, and I'm not actually doing the min-max yet. What I'm doing is I'm just making each of the other players take a random move, and I'm counting to see what happens. And the best resulting score in the end is based on their random move, and I have to actually do the min-max part. But I'm going to submit this as is. So that is right now, I have the score next direction. No, I have the score step lock. and it predicts it predicts the move each other player takes by taking a random next direction. And this is where I should actually change this to take the one that impedes on us the most. And that is, I believe that impacts our score the most. So if they walk directly towards us, and that means each of these steps, instead of taking a random direction, I should make the opponent walk the worst possible way for us. And I'm trying to think that walks into our territory. So that would be the one with the closest distance to us. And I can probably do that by, again, another flood filling type algorithm, which would be basically an A star, and I just measure the distance. Or, yeah. I'm trying to think. I'm trying to be lazy and not actually do the A star. What I basically do is, if I knew right here the directions, I would basically just say pick the next closest direction. Which one gets us closest to me, and that would be the min-max. That would be the one that basically says, look, they walked right towards us. It's the worst possible thing they can do. Now what do you do? But at the same time, that may also be the best possible thing they can do. Because, yeah, that would be... Why would that be? That would be because it might end up killing them. Or could it? Would it end up killing them? So it's hard to say for sure what it would do. Or I can actually use the same function we have. If we take our score next direction and we score it for all of them, and this gets really expensive, and we actually make them take the best direction based on our own strategy, we can test that first. Let's test that approach. This is like super slow, but I don't care. Just comment this all out. Direction, comma, I don't care about the score, equal score next direction, and state, and alright, so we have to choose a player though. So our score next direction is actually going to have to take a player now. It's going to take P. And then we're going to do state.board.set. We need to know the direction. We need to know the direction, and np equals state.heads p as usize dot step dir state.heads p equals np. And this will actually, according to our own algorithm, for each step, will make the opponent take the step that's best for him. And so this has to take a player ID. Player is going to be I32. And I'm going to take player. And score location should also take a player now. And where is score location? Score location. Player I32. And play the board. We're going to clone it. Heads player. It's use size. Set that player. Player. It's not really our score anymore. It's player score, but I'm going to leave it. Still makes sense. Player. And we remove all the other scores. So this is going to be based on our own strategy. I don't know if that'll help or not. It's not truly min-max. Um, 353. Let. I guess let would be the correct word. $352. 352. What's our problem here? Score next direction. PSI32. Did it not have that crate that way? Well, let's see if it allows that. I thought that's what I did though. But we'll try to see if it compiles that way again after I fix this one, 315. Score next direction. Takes 2 parameters, but 1 was supplied in 369. And this should be state.player.id. Okay. Don't think I actually need the random now if we're going to fix this the other way. Now, did we just take too long this time? Shit. I think we're just taking too long. Let's reduce the count step lock to just 2 again. But it accepted the extern crate, so we should be okay with that. Now our current submission is doing really poorly, so the looking ahead didn't actually help us. Because we've lost here. It looks like he has more space than we do. Which is bad, 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 bad. But what's happened to our last submission? Why are we so poor? So some change we made last time made it far, far worse. Now I wish I had versions. I don't remember what I changed. I don't remember what I submitted. Let's go to a depth of 1 and just submit the code. Let's see how far we get. I had to figure out what actually made the difference. The looking ahead was not good. Making it go further depth was a problem, but that would actually be... how much load this puts in their server if we're all actually taking 100 milliseconds of time. What have we done? What did I change? We're doing horribly now. Oh, there's a whole bunch of wins. Why is it so bad here and then suddenly so good up there? It's weird. Still making shitty decisions when the board's empty. I don't know why that is. Like, why on earth did I do that? Something wrong with my scoring, I guess. Let's put this back to 0. Just don't check. Submit that. Always shows me as losing battles. We keep fighting the same people. Is that all we have here? Or is this because it's the same board? Okay, so whatever we've done, we've broken something. That's bad. It's bad, it's bad, 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 bad. And I don't remember what I broke. When it's going up, it may just be really super slow. In the meantime, I don't think we can use this approach here. Because that's just too slow. That's doing too many calculations. So what we need to do is we need to find the area where they're closest to us. And the way we can do that is right after we move ourselves, we can fill the board with just us, because then the positions beside their open heads will tell us the position that's closest to us and lets us move it directly towards us. And so let's do it that way. So what I mean is that whenever I take a step, the moment I've decided what I'm going to do, I've stepped here, I'm going to fill the board to figure out for all the other opponents how far they are away from me. And filling the board, it's probably more efficient just to fill the whole board than to try and find optimal approaches, because if I add more if statements, I might just make it go slower. So I fill it, and then for each head, I take the one that goes closest to me. Alright, so how do we do that? And where's our fill? We're going to copy a fill, but we need to change the filling. This didn't work. Take one direction. We're splitting. For fill, what we want to do is we want to fill it up for just one player. Okay. Okay, where am I? Score step lock. So now let mut close board equals state.board.clone. And then I'm going to fill this one. I'm going to fill and mut close board. And wait a second, distance board, what's that? Why do I need two again? Who else is calling fill? How do they call this again? Playboard and distance board. I have to clone them both? That seems weird. Why would I have to clone them? Alright, because it's going to fill it in. Do I actually have the same thing, distance board and clone board? Distance board I just create a new one of. This looks like a little bit of duplication of the code. Well, let's just do it. And this is where if we knew Rust a little bit better, we could probably, if this allocation is costing us stuff, it may be a problem there, but I don't know how much allocation time is going to cost. The state board width, distboard.fill. This is probably costing us a lot of waste, but that's okay. I'm going to take we'll call this clone board instead, because we're just going to discard it. Clone board, and distance board, and mut distance board. And now we only want one head though and one player. So that's why we said we can make the other ones -1, and the skill Fill will do nothing with it. Heads equals -1. How do we do that now? How do I create... Oh man, this is... Heads equal... Where's our state for heads? This would be vec point 2. 0 -1, -1. And state.heads.len. Heads state.player ID equals state heads state player ID. And I just want to pass it off to here as heads. I'm just trying to reuse this stuff. It's very suboptimal. And I want to reuse this fill function. So basically what the fill should be doing now is it's filling the board with just our player. And just our player then basically means it'll all the empty spaces will have the distance from our player, how far they are. So this board at these points will be the ones that are the closest and the distance away. So we're going to have the same similar array here. Let's say for and D in all ders. And we want to find the best dir. Let best dir equal direction left. Let best distance equal standard I32 max. Let NP equal state dot heads P as use size dot step D. If board is free and state.board comma NP, then we check. We're going to have the score, and we're going to say close distance. Then we have this one. We have the distance board dot get at NP. Close distance is less than best distance. Then we're going to set it so the best dir becomes best dir equals D. Best distance equals close distance. So the idea here is that we'll find for the enemies, and this is actually, I'm hoping this is a min-max. I'm hoping that when they intrude in our area, that's the worst possible thing I can do. So we're going to account for that. And it's not necessarily correct, but we'll probably have to get better. So our ranking's going up by not looking in the future. So our clearly looking to the future was a bad idea. So our rank's going up without looking into the future. So now we have this NP. We know which the best diction is. NP states its head step best dir. And we just set that. And I think we made a mistake here. We forgot to set the board here. To do set board.set. So we actually have to set it too. That might have actually made a difference in it. That might be the reason why it didn't work, but I don't think so. Let's see if this compiles. Let's see how we do anything here. Play my code. Three, 4, 8. Alright, so I have, this has to be a macro, I think. This is the macro that does this vector. Alright, that's all about that line. Okay. 349. As use size. reduce size. 386. What's 386? Best distance. Alright, here we go. Let's see if this works. No. Reassignment of immutable. That's fine. Did these actually work yet? No. Still can't click on it to go to the right place. 378. Wish I could code as fast as I could think the stuff. There's a strategy. Just follow the strategy. Okay, it looks like we actually compiled this time. Are the ranks 111? So that's looking good there. Don't know if this is helpful. We made some stupid decisions again. We blocked ourselves in really fast. Yeah, why don't I use it? Because I make too many small changes in this editor. And because if I make a small change here and forget to copy it out, I'm going to have a mismatch. But I'm thinking I almost have to do that because this is getting way too hard to modify the code here. I keep making simple, stupid mistakes. Let's see if we do any better this way. Submit it. We are 151. We made it up to 80 with nothing before. Let's step 3 in the future and let's see if we can actually get this playing my code. If the stepping forward approach doesn't work, we're going to have to evaluate what's going wrong with the code. And that was a really stupid move of me. Incorrect movement. Okay, so we actually have a... Yeah, the compilation is a bit long. For the other ones, we could actually just compile and test offline, but with these battles without these other robots, there's not much we can actually test offline. Alright, I know why we died there. It's because we took a location that's actually not possible. And why on earth would I have gone up? Okay, I think our scoring's wrong. We're doing something wrong with the scoring. When we get trapped in, we do okay. Clearly we won here, but that was more just of a luck thing. How are we doing in the leaderboard in this submit? Probably poorly. Going up, but ever so slowly. What is actually the battle's looking like? Well, we don't have a lot of last positions. That's mainly because we aren't playing 4 players. So we're sitting at the front, which means we may have done, but a lot of cases we just... Like this flipping back and forth, I mean, this is just basically, I think this is just flipping the starting positions, as somebody mentioned last time. And let's check the starting positions. Yeah, that's just flipping starting positions. So a lot of them ones we're not doing anything better, we're doing it just worse. So I'm going to start thinking there's something wrong with our scoring function, not looking ahead. So looking ahead's not getting us much at anything. It got us something when we set it down to 1, but not very much. So a 1-step look ahead worked, but 2-step didn't. And that's because we're just taking the next move. We're not actually evaluating further down, not doing any balancing. So let's put back to 1. And the random positioning I don't think makes sense. I think so far this is the best one for the mini-max, is that for each of the other players, just walk them towards us one. We walk towards us and then we figure out what's happening there. And state heads, so state board set NPMP. And then we score ourselves, which is fine. And this perpend here, we fill it in. Okay, now there must be something wrong with scoring. So let's return to the scoring, and where do we fundamentally take the scoring? Count scores. We don't fill multiple directions anymore. We got rid of that, but that's okay. And max scores. Where do we do count scores? Count scores. This is where we subtract all the opponent's scores. I have a feeling this is actually making us be worse. So let's count it this way. Let's mut max opponent equals 0, I32. Let mut total opponent 0, I32. Take this off for a second. Let's say max opponent equals max opponent dot max scores I. We'll try two different approaches. Total opponent plus equals scores I. And then our score minus equals. Let's take the max score because we were doing the total before. Now let's take the max instead. So the other alternative is to our score minus equals total opponent score. And our ranking seems to be doing very poorly with this new run, so we're going to figure it out. And we really should do checkpoints. Wow, that's like, we're probably in here somewhere. Yeah, and this is the part, I mean, because I still have so many compilation errors, copying back and forth would not be so nice, but the amount of time I press up and down, maybe it would be. What? Total. Fine. Now, this one actually bugs me, because total app's actually technically being used in here, but I might disable the warnings. The reason I have warnings turning to errors is because there's some that when code gen runs, I mean encoding game runs, it hides all the warnings when it's successful, and sometimes we need those warnings because sometimes they're actually errors. So we don't even have to open this screen. We can look what we're doing here. We're number 2. Number 2 was doing okay there. Number 2 did far better this time. Look at our row. No. We did horribly. I have a different output there. Oh, so we did horribly there. Wonderful. I don't think it's a compilation that's taking long. I think it's their system taking a long time. So we totally let ourselves get cut off with this approach. So it makes more sense to take the total opponent off. Yeah, that's true. I could actually compile it on my machine. Am I taking too long? Well, interesting. We set an index of this. So we have an error there somewhere. It's supposed to be costing something. So I'm gonna analyze this a bit. But it looks like total score makes more sense. We're taking the worst of the worst. But I might have to copy this out and clean it up because to do debugging here is just impossible. I can't trace the code here. Oh man, this is the part I don't like. Okay, so we're gonna have to get rid of. We can just do both of these. Actually, take max op, total op, max op. Yeah, this is looking really like I should be using an external editor. $200. Okay, and the reason I do these weird maneuvers is because of this scoring. Because when I was right here, I don't cut blue off because then that would let pink come in. And so we're actually scoring to cut them both off. And that's always screwing us up though. And that's why I thought if I took the maximum opponent instead, but this move here seems really weird. Why did I go down? Alright, let's put back this up. Oh, you guys probably can't see that over there. Let's back this up. Why on earth did I go down? That's definitely a scoring mistake. No, it's not. Every direction had the same score because I completely... No, I should have gone left. If I went left, I would have covered more area than pink. No, I know why I did that. So the reason why it went down, if you think of the scoring, it goes here and it checks from this direction, and it's cut it off to the left and right. And so it starts filling here and it starts filling down here, but this one starts filling this way as well. And if it goes down, it doesn't cut it off, so the step forward, it's able to fill around the corner and get more to that direction, I think. So it combines the two sides off. Which is weird. So that would mean our step forward is actually doing a bad thing. So what I want to check is if I don't do any forward looking, if I just do the one step, and actually do the max opponent instead of the one step. And what I actually want to do too is make sure this score next direction with the depth, the one that has the depth in it. What I'd actually like to do is just say skip this whole thing. No, how do I actually do that? I want to skip this whole thing. Actually, this doesn't matter. If I let them step 2, it's not a big deal. Alright, that shouldn't make a big difference. If we let them step or I step, it'll make only a minor difference in the code. But let's not do any depth. Their depth is not working as well as I thought. I mean, this looks good so far, but you notice how he turns back? This is because blue's over here. We're worried about blue and red at the same time. Then we get boxed in. And we do something stupid. And this is the stupid part I don't like here. Why is it doing that? And it's because the scoring is off. But we would have lost this anyways. Yeah, we just lost there. Alright, we're going to have to think about what I did do. I'm not so sure that scoring made a difference. Okay, where are we? We're just doing horribly. I don't have to look. Okay, not doing so well in the Gold League, but we got up to 86 once. At least let's get back to... Let's figure out where we're at with 86. We had the 0, and count scores was the issue. Count scores was doing the best. What was I calling that? When I took the total opponent score off, that was so far doing the best. And I'm going to see if that was actually the best one we had. Because that'll be our working point for doing any more from this. Why am I not stepping towards the walls? This is really getting annoying. Because that one I found the way out. It always looks nice when you have a bunch of wins there. Two-player we're still fine with, and it's the multiple players the issue here. Yeah, it's the moment we have multiple players, which would imply our scoring algorithm is somehow wrong. So against 2 players we do just fine. And yeah, we're missing some very easy area. Question is why? And Now I'm wondering if we should just be ignoring players that we can't access. Look at that orange guy up there. The orange guy likes filling area. So he's doing something really interesting. I don't remember how we got to 86 though. I don't know what options we were using. And I think it all has to do to the scoring right now. It's not even looking ahead, because I'm not looking ahead right now. Let me make sure I'm not looking ahead. Count scores. Okay, we have all these scores. This should be fine. And max scores. If we take the max, that's fine, but we're only using one variant, we're not using multiple ones. So fill right now. We took out the one where you're having, we don't care about splitting right now. We push it back, we take the lead, players I32, so that's the score, that's the player. Our filling is working, I think. Clearing should be fine. Next direction. For next direction, we go through all the directions and we say, what's the score at this location? Score step location. In score step location at 0. Yeah, let's actually just put a for loop here. For I in, or for depth in 0 dot dot depth. Let's make this the loop. So this won't execute at all if we have a 0 depth. Tab. And no, I like the recursion. It's a bit harder to read, but that's going to be hard to see because I can't force the width wider than this. And if I have to put a 2-digit number and a spacer, I'm not going to be able to see it. But I'd like to show the distance each time. Trying to think what I could do. Well, let's actually compare back to this again. Let's just ignore this. I have something wrong in the range, and I'm going to have to do this in the external editor because I can't see that function well enough to refactor it. And let's just do this. Let's just skip the logic altogether. Skip my stepping and just work strictly with the filling. Of course we have errors. 312. Yeah, this is just reaffirming that I really have to use an external editor. It's just getting annoying. This is unusable. It's just making it frustrating because I can't easily play with the code. Score next direction is No, I can't do that anymore because this just takes... Wait a second. Yeah. Why on earth am I doing... Okay, this whole thing goes away. I got that wrong. So this whole function goes away. And I really, if I could see this all, I could actually refactor it a bit. Because I have a feeling we have a really simple logic error. And actually, externally, we could just make this play against ourselves. I couldn't do any graphical output, but... cut ourselves off there. How am I doing with the current thing I submitted? Am I going up or down? So this is going up, so that might be the version we won. But I think what I have to do is I'm going to have to actually get the external editor working and copy the code. And I'll do that for next time. Hopefully this plugin will actually work. Because what we're missing here is I have no overview here. I can't see what my code is doing. I don't... And I need to refactor this, but in this editor there's no way for me to copy bits around it without totally destroying stuff. And so I can't really see what's happening, and I can't really refactor the code here, so I can't really play with it. Because we should be able to quickly play with the scoring functions. Because the basic approach we have is we have two things we have to look at. The scoring function, we have to check, improve the scoring to figure out what the value of the scores are. And then we have to do the prediction function where we do multiple steps, whether that's actually helping us or not. But I need a way to see it. And as Winter Squirrel says, I need a way to debug this. I need a way to say for each tile, what is the score for each one? Does it make sense? And then we'll step it that way. But I have to get this external editor working first. I'm going to set it up. And I mean, I could copy and paste now, but I don't even have the Rust on the right directory in the command line. So I have to do that first. So I'm going to leave it for today like this. Thank you for bearing with me. We never got any further. I mean, we got in the Gold League simply because last time we got there, we got up to rank 80 somehow. So we know inside here we have an algorithm that kind of works. And it's not just a matter of tweaking. If we could see where we had to tweak, maybe. And then once I get an external editor, I'll actually just refactor it a bit so we can clean it up. And I might do a little bit of offline cleaning up so that when we come back tomorrow, we can actually follow what my code is doing again, because I think I'm paging up and down so often following the errors. And then I'll try to get a workflow working where I can work offline and not deal with this crappy editor here, and then maybe we can make some progress, because I said there's only a few things that you really have to work on. Is the general approach to these things is the scoring function and the prediction function. For each of our possible options, let's score it as the board is, and then for each of those, let's take a step into the future, and that's where the minimax comes from. Make the opponent take the worst step. And I think we were doing that, the opponent stepping towards us, which I think is the worst step, which reduces our score in the moat, but we want to test that as well. And maybe I can make some offline code. I mean, I could at least make code that pits us against ourselves, right? Like I could take 3 of these and make classes and stuff, and we could offline actually play against ourselves to make sure we're not doing something stupid, at least to be faster. But I'll leave it for that. So I hope you enjoyed watching anyways. We didn't make much progress in here, but we should be able to get further tomorrow, and I'll work that out. And hopefully tomorrow at the same time I'll be online again, maybe a tad bit later, I'm not sure yet. I'll be somewhere until 10 and I have to get back. Or earlier if I get tired of work. But that's all for the program. Thank you very much, and I hope you join me again next time. and we're gonna get the Platinum League here somehow. We'll get the Platinum League and then see what happens. All right. Thank you.